so first things first, yesterday's lesson and today's lesson are essentially combined. I should throw this on this screen while the video starts, I guess. So, does anybody have questions remaining from 422 yesterday? About proportional relationships, finding the unit rate. We talked a decent amount about this stuff. Sorry that I was sick yesterday. I apologize. I can't help my body. I want a new one. They said it will take a while to get a trade-in. I love Goosebumps. Anybody? Oh, sorry. Yesterday was 423. Today's 424. So 423. Any questions from there yesterday? How was the guest teacher? Awesome. Okay. That's the best thing I've heard out of you guys all year. Is he like a real math guy? Muy bien. All right. So 424. I'm gonna swap my screens around here. So at your table groups, please have at least a book, probably 2 books open. Your homework is 60 to 66, but the review and preview section goes up to 69. If you would like to challenge yourself and do a couple extra problems, that is up to you. But the minimum I will be expecting is 60 to 66. Does anybody like, ahead of us or whatever else, anybody know what a constant of proportionality is? Seems like a really big word. We normally get scared of big words, right? Like onomatopoeia or Mississippi, or those big words. I'm afraid of Mississippi just because it's so long. Oh, by the way, so I should get these handed out. I'm gonna be lazy and make you guys get up because we keep changing desk groups, and then I just get lost and it just takes longer than I need to. So please come get these. Before I give these out, I need you to see me. I need you to hear me. So hands down, flat on your desk, cross, whatever, eyes on me. Whatever you need to do so that you can actually listen. Sit, because I can't see everything. My masteries will vary, V-A-R-Y, how you go from progressing to mastery. So, for this mastery assessment, because I'm still learning who you guys are and still experimenting, and you guys are kind of like guinea pigs right now, this is one way that I will do a progressing to mastery. So we have already done step 1 together, which is to revise. Right? We went back, we checked our answers, we saw what we got wrong. For most all of the problems, we were able to go back and revise. So part 2, and this is where you're going to come in, and you might need to write this down in your plan book and like the to-do list if you're progressing. This only matters if you're progressing, right? If you're already at mastery, you don't need to do this. You can, if you'd like to. Part 2 is going to be make up problems, not problems. Problems. Sorry, my eraser's too far away. Make up problems, which means if I go into my test and I have a progressing, now Alex doesn't, but I'm going to pick on Alex. Let's say Alex's test, I'm making this up. It doesn't matter. Let's say Alex's test had a progressing and number 8, multiplying mixed numbers, was one of the problems that I missed. In the test, it says 3 1/4 times 6 1/8. When I go to do my progressing to mastery, and you can literally label your paper progressing to mastery, like that can be your label. And sometimes I will make these as a separate test, but because I want less work for you this time, you only do this with problems that you miss, right? So I wouldn't do it for every problem. Let's say I missed 8, multiplying mixed numbers. I will make up my own problem like that. So instead of 3 1/4, maybe I start with 2 1/2 times, and they had 6 1/8. Maybe I go 8 1/6. I don't know, I'm just making stuff up. All you have to do is show that you know how to do this. You're not trying to get like some answer that I'm looking for. You're making up your own problems. So if you need to make up an easier one to show that you know how to multiply mixed numbers, that's okay. If you want to make up a harder one to show like, hey man, I had a brain fart the first time, I really do know what I'm doing. Let me show you how much of a boss I am at this. You can make it as hard as you want, but it's up to you. Does that make sense, or how to go from progression to mastery right now? Those directions will be written in math also. So if you go into math for any grades of mine, if you are progressing and you go to the assignment, it will say, if progressing, students should, whatever. So come and grab these as I call your name, please. Miss Lee, Miss Koenig, everybody, Miss Barker, Izzy, Bouvier, Ava, May you're right here. Ava, yeah, Bouvier, Alana, Alex, Valentino, Sky, Sky, Naya. Oh, that also goes, Oliver. If you weren't finished and you didn't make it to some problems, just make up your own problems like that. Annie, Zach, Ian. So for some of you, if you're confused about your grades, some of you like have it progressing and then I made it a mastery, or vice versa. You had a mastery and then I was like, actually I'd like to see something. Zin, Piper, Bilal. Essentially, if you haven't gotten your test back, you can just come up here. Zin, Piper, Bilal, Will. So here's what's up with my grades being a little confusing. For some of you, I was very much on the fence, and when I made the decision, if you want to hear like why, because you're one of the people that like was on the fence, when I made the decision that progressing to mastery would be you making up problems, even if you only missed like 1 or 2 problems, it's worth it to go back and try those again. So a couple of you, and this is what's dangerous about mastery, if you compare paper to paper, this doesn't work. Because I've worked with some of you individually, I've seen your work, I've seen your mastery. Some of you will have mastery with a couple mistakes on your test. Some of you might have the same mistakes on your test and have it progressing. Because I want to see you do it again, because I'm not 100% confident. So even those of you with mastery, you could benefit from going back and making up a couple new problems like what you missed. You don't have to, but you could very much stand to benefit from trying that again. So please do not try to compare paper to paper and expect it to be like easily comparable. It does not work like that. So progressing to mastery, if you have it progressing, the problems you missed the first time, I know we went back and fixed them, but the problems you missed the first time, make up a new problem. Please don't try to play the game and like skip problems or hide them, or like, I don't like games. Just come see me if you need help. I will be more than happy to help you. So let's look at our lesson now, diving back into constant of proportionality. This is a really big scary word that doesn't need to be scary, and I don't know why they made it so big. Well, I do. I mean, it describes exactly what it is. What does it mean when something is constant? It is what it is, right? It's not going to change the entire time we work with it. What does it mean when something is proportional? We've been talking about this for a couple days now. What does it mean for something to be proportional? All right, we'll make it a situation where you would care. How could that saltwater taffy and you become involved in a proportional relationship?
I get 5.
Ian?
Yes.
I said how.
Oh. Yes. Yes.
7.
She gets that. No, you should get it. You get one. No. Yes.
Other done.
No. Yes.
Too late. So say that I have no saltwater taffy and then there's still the same amount in there. And so candy also takes 2, so we both have 2 now. There's 4 missing. You keep going up until that there's 0 left, and if you have the full amount.
So what relationship could we then say where we would involve the word per? Right? Because we talk about rates using per. So what if I said, I'm going to give out that saltwater taffy, which I can't, and it was a gift from Stephen Mott, so I appreciate it. But I'm using it for some prizes as we go through class, so potentially you might get some of those. So what if I say I'm going to give out 2 pieces of taffy per student? How many pieces would I need to give my empty class, my plan period, my 0 kid period? 0, right? I need no candy for no kids. How many pieces of candy would I need for 10 kids?
20.
What about 20 kids?
40.
And you can quickly find this relationship because of this. The constant of proportionality. Everybody in your notes or toolkit, whatever you're writing in right now, write the equation y equals kx. And very close to it, write also the equation y equals mx. Now, this is very, very confusing. Anybody a twin in here? Okay, I grew up with 2 different sets of twins. Neither of which could I really tell who was who. Now, finally I figured out the difference between Jamie and Devin. And Jamie and Devin are twins, but they start with 2 different letters, right? J and D. They're twins, but they look exactly the same. They are exactly the same. But they have 2 different names. But actually, they could both do the same thing. They're both really strong. They both play soccer. They're both referees. They're both the same. I'm talking about real people here, actually. I'm not making this up. Jamie and Devin Dooling, they're great guys. Their mom was my language arts teacher in middle school. M and K are twins. These guys are the same. They're twins. They are identical. We just call them 2 different things. They both represent the constant of proportionality. So please, somehow on your paper, mark that the constant of proportionality is the M or it is the K, regardless of which one we're using. They both represent the constant of proportionality. Now, this is another one of those I'm sorry moments. Somewhere along the way, one branch of mathematicians wanted to use the equation y equals mx, m standing for a measure of proportionality. Another branch of mathematicians said, look, m gets overused. It's very similar to n. Let's name this based off what it actually is. It's not really a measure. It's more of a constant of proportionality because it can't change. If I give you 2 pieces of candy and you 2 pieces of candy, I can't then switch and give May 3. That's not fair, right? Mathematicians want to be fair. We want to be nice and even and proportional. So instead of using the letter C, because that's dangerously close to a 0 and looks like a lot of other things, we went to a letter that doesn't get used very often and said, well, K sounds like constant. Constant K. So they use K for constant of proportionality. I don't care which you use, but you need to understand they are interchangeable. Okay, sometimes we'll use M, especially for slope. We'll use M when we talk about slope. Sometimes we'll use K. Either one's the same. Cool? Questions, issues. I'm upset about it too, but we just gotta roll. I took a picture. Or we're going to start the song Freeze Frame. Nobody? Okay. So, we can, there's a song called Freeze Frame that starts with like picture taking sound. We can know the rule. We can see the graph. We can read from a table. And we can hear from like a verbal or a written situation. All of these can lead us to a constant proportionality. Or a constant proportionality can lead out to all of those. So we're going to look at how we can determine this based off situations. So, Grammy, I think. Grammy earns $4.23 for each half hour that he works. What an awkward, like somebody was getting rid of pennies here, $4.23. So, how much money does he earn during a given amount of time? Let's make a table. Now, always, our time, is it independent or dependent?
Independent because it doesn't care about you.
Time doesn't care what you do. Time is independent. So make a table. Yeah, I'm just going to squeeze one in over here. So I'm going to make a table with, I'm going to say T for time and maybe M for money. I don't know. Doesn't matter. Yeah, well, we like having some kind of letter or something. It's hard to just use a dollar sign. Like, we could, but we like to use a variable, like some kind of letter. So my time is a half. What did he make?
$4.26.
Fill in a table however you think you would. Like I said at the beginning of the year, I'm not lazy, I'm efficient. But I think it'd probably be easy to double. You can do whatever you want. But I'm going to take the easy route.
So for time, we're basing off of hours. That's what the first one said.
Yeah, so this is time, and you can make a note somewhere that, like,
Hours.
now you could write yours in minutes if you really wanted. You could do 30 and 60 and 120 and
I'm just putting hours. So it's 1/2 of it.
you could, yeah. Your table can look however you want it to. Now, the reason I did my table like this, 8 hours is a full day of work. 8 hours is a work day, right? So I'm just curious, what would he make if he worked for a full work day? 8.46. I was talking about this with somebody the other day about the minimum wage. There's always a legal, what is the least somebody could pay you, which is always kind of in my mind like insulting. I'm going to pay you the absolute least I can. And right now, it's around $8, somewhere around there.
Yeah,
Over
it's between like $7.40 and something and $8.
Yeah.
Last I remember, but I think it
It's
changes.
changing almost every
I'm
year.
pretty sure it's like 8.25.
Yeah, we could look it up too.
I need to
So
try.
then if I double again on my X, I double again on my Y. So 1692. Now you might have different values on your table. And we could keep filling this in. I'd end up with like 33.84. And then in a day, he might make $67.68. The unit rate is always for your X value equaling 1. Your unit rate always, because we talked about unit rate, something has to be 1. It's your independent. X is always our independent. Our independent has to equal 1. So what's our unit rate here? Izzy? And we would write it $8.46 per hour. And if you want to be real specific, put a 1. That's per 1 hour. How can we determine if the relationship is proportional? What did we talk about yesterday, or a couple days ago? For the past few days we've been talking. Alex?
If it's a constant slope,
Constant
it
slope.
goes through the origin.
Through the origin. So straight line through the origin. If we graph this, would we see that? Well, if he works 0 hours, how much money does he get? 0 money. If he works 10 hours, well, he gets 10 times the 1 hour. Now, the only way that this could not be proportional is if there was like an added situation, like at 5 hours, he gets a bonus. Or once he works more than 4, he gets paid more. But it doesn't, right? It's just flat. They get paid that awkward amount of money every half hour. It's a proportional rate. Questions? Cool. Now, we can also create situations where proportionality is way in our favor. Where if you go to shovel driveways this winter, it's expected that we're going to have a wet winter. And you charge, so think about these two different situations. I'm going to give you two different unit rates. Think about what if you charge per driveway and go house to house to house. $20 a driveway, $10 a driveway, something like that. Or what if you charge per 10 minutes or per 20 minutes? Like pick a chunk of time and that's your one unit. Now you could charge per hour, but I doubt you're going to be shoveling one driveway for multiple hours. I sure hope not. What's the danger with unit rates like per driveway versus per time? Will?
Per time would just be like more confusing because say if you did $5 for 20 minutes or something, and then you worked for 37 minutes, you would have to.
We could compute that out, but it would be complicated. I do agree.
That would be way hard instead of being like, I'll do your driveway for $25 straight out or something.
So you look at the average driveway, right? Average driveway. Piper, what were you gonna say?
I was gonna say that if you're doing it based on driveways, it's more, for lack of a better word, equal. For lack of a better word, because if
For
you
who?
have, for the people paying, because if you do it based on the driveway and like if you do it based on size, like you say, then people with the same size driveway would pay the same amount. Whereas if you did it based on time, they could pay different amounts based on how tired you are from doing previous events, how cold it is, human error, like just general outside influences.
If Will shows up to my door, I'm going to take everything you just said and amalgamize it. Will shows up to my door. He's sweaty, he's huffing and puffing. Hey, Mr. Hudson, can I show you your driveway? I'll charge you just $5 every 10 minutes. Do I think he's going to work very quickly?
No.
He's like huffing and puffing and like about to hyperventilate. I'm like, dude, you need some cocoa. But if he shows up and he's like, hey, I'll show you your driveway, $20, however long it takes. Probably take that deal, right? Like my driveway, by the way, if you're trick-or-treating tonight, I'm giving out candy. My driveway is 50 feet long. Not joking, I've measured it because I had to seal cut. It's 50 feet long. It's huge. Shoveling my driveway will take a long time. So if Will wants to make more money, he should charge me by time. But if I want the better deal, I'm going to make the agreement per driveway. And this is where unit rates can be chosen in different manners. Yeah.
Couldn't he take someone with a really long driveway and say, I'm going to do time, and then someone with a short driveway?
If the person paying agrees.
See,
that's the thing. As long as no one, by the way, I would never know that.
Ooh. But you do have to tell the person who's paying, right? So like when I did it, it was always like how much per driveway. But then you get to that big driveway and you're like, I have a bad pricing model. Because you're charging them the same amount for a driveway that's twice as big. That's not, now hold on, here's what I'm getting to. If you charge per driveway, is that really proportional for your work? No. Even though it's a proportional relationship per driveway, it's not really proportional for your work. So we got to move on now. Yeah. Here, I'll put this out. This is dangerous, but I only give you a quadrant. Okay, this is as much as I'll give you. Smoky. Right, Smoky Row Fire Station. Fire station right here. Little Caesars.
Yeah, I know exactly where it is. I'm 5 houses down from you.
Don't tell your friends then. That's no fun. This is Hard Road. And this is Billingsley. And if I'm going to leave it wide open, we'll say that this is Sawmill. Now I will tell you, technically, I'm a Dublinite. I live in Dublin. Technically, I live in Dublin. So, but I'm in that quadrant, in that neighborhood. I do not give out my address, but most people find me eventually because I work in my yard a lot. So if you're in my neighborhood, you're going to end up seeing me or my car. I will be a penguin tonight. If so Snickers and Three Musketeers are legit candy. Heck no. You know I'm a teacher, right? You know that I'm a teacher. Yes? Yeah?
I wrote this down.
Nice. Alright.
I'm
Now,
gonna find you.
I will answer yes or no questions later. But 56, check it out. As your team, dive into it. That's faulty wood. 59, check it out. Or 56 with your team. Hard road, smoky road at that intersection. Like where CVS and everything is. Now, I'll make this mathy, and this is the last thing I'll say, because I always do find it interesting who tries to find me and who doesn't. I live at a very average location in the neighborhood. What does averaging a set do? Yeah? What does averaging a set of numbers do?
Oh. Gives you the middle.
Puts you in the middle, right?
You're in the middle. You're in the middle.
So, I don't live right by Little Caesar. I don't live right by I'm an average point in the neighborhood. So, I'm deciding whether I'll leave my car out or not. It'd be too easy if I leave my car out. I'll probably put it in the garage. You'll know it's DJ Hudcap's house if you find it. 56! Did you guys get long enough? So refocus. We're done with that conversation. Cut it off, rip it off, throw it away, whatever. 56. I'm going to highlight the important stuff. Talk about it as your group.
That's pretty fast.
That is really fast.
Maybe that's an app. Maybe she doesn't actually do that. Has anyone ever run? Maybe she ran.
It's a set of world record. Probably. People have recited digits of pi for like an entire day. Like speaking. Yeah, you can look at videos of people that are just set numbers, just like a fact, hours. You can look it up. It's like 68,000 or something like that. Please tomorrow. Yeah, I'll get tomorrow. I'm making the schedule right now. I can print the schedule if you want to know who's working. Speed is always time denominator. You never put time on top because you want to put what you're traveling on top. Is it feet? Is it meters? Is it miles? Is it kilometers? Like whatever it is, what you're traveling per time. So when we set this problem up, we've all talked today. Rachel, how should I set up this rate division? Well, so it says with a graph, but what did you do to start?
Well, I just made like a graph that was like so I there's a horizontal line and then like
Kind of like this?
well, I made a chart, not a graph.
You made it. Oh, you made like a T-chart? So that is not a graph. So charts and graphs are two different things, right? Graphs plot points. Charts have like numbers and things on them, right? So a graph wouldn't have the numbers on it. If we look at this relationship and we see it's proportional, you can just make up a graph because you know it's a straight line through the orbit. Then you could assign it some points. Now, you could do like values first and then make your line, but I know that at 1.5 hours, I ran 9.3 miles. So I could literally do this. It's going to be gross and ugly. Then double it. Right? If I go twice as far, how many hours? 3. 18.6. I could do this again, 4.5. Go up by that same interval that we went up. Go up by the same interval that we went up. Either way, what it's trying to get you to do is just quickly, you know it's straight line through the origin. It's trying to push that again. Straight line through the origin, and then just some points on it. Now, when we talk about the constant of proportionality, that's where we have to do that division that we talked about. So that constant, by the way, it's up on the TV. Once it disappears here, it's up on the TV. I know it gets a little bit smaller. That constant proportionality is dependent divided by independent. What you're actually doing here, constant proportionality, let's label this K. To find the K, you're taking the given Y value and dividing it by the given X value. Okay, so sometimes I do, that's not an R. That is lowercase k. But a lot of times I just do uppercase k. But that is a lowercase k. Yeah. And it does look like it's an R that I just went too far with. But, so that's a lowercase k, which a lot of times they use lowercase letters in math because uppercase might mean something different. So a lot of times, whatever case they use, lower, upper, copy that. So if they use lower, use lower. If they use upper, use upper. But K is weird because it's a weird letter. It's the Y over the X. My X is independent. It's my time, 1.5. My Y is the dependent. How far can we go? So 9.3. When we do that division, what do we get?
6.2.
6.2? What?
Miles
Miles
per hour.
per, because this was miles. This, well, is hours. So my division gives me my answer, numerator divided by denominator, miles per hour. Now, when we first looked at this problem, Will and I were both like, man, that's pretty fast. But if I'm being chased, I can run 6.2. Not for very long.
Consistently, that's hard.
Right. Now, I have long legs, so I can actually average about a 6-mile pace. But if you were going to do this consistently, that's, I mean, to keep this up, what if they run for 3 hours? Approximately, let's not be exact here, approximately how far would they run? 18. Now, if we want to get exact, yeah, 18.6. But if they slow down a tiny bit and they run about 18. This is how you set goals, right? Yesterday I ran this far in this amount of time. I can compute how fast I ran. This is what your Fitbit does, your Apple Watch, whatever. It computes the unit rate for you. You don't have to run for a whole hour to figure out your rate per hour. And you can run longer than an hour and still figure out your rate per hour. But this will be an average, because we know you probably didn't run the exact same speed the whole time. So that's your average unit rate. Well,
Like, if you went to 5 hours, you could easily just run for 5 minutes and then multiply.
by 20. But the problem is, could you keep that speed for an hour?
It gives you an average.
It gives you a max almost. Try 57 with your team. Try 57 with your team. Wouldn't what? About what? For 5. Oh, for 100. Yes. I was thinking to get to 100. Yeah, no, you do multiply by 12. That's the problem with our base changing systems. Can you take somebody trick or treating? Do you have any younger siblings?
I have 4.
I don't know. I still don't know if I'm only gonna. I'll at least be there until 7. I tutor. Hopefully I'll be there by 6, but I tutor this evening, so I gotta zip home after tutoring. Hopefully I'll be there by 6, and I'll for sure be out until 7. We might. My wife is helping with a family of 2 babysits for her, so I might go over there at 7, but I might just stay at our place. So if you guys are coming to hunt for me, I'll stay at my place. Or I'll at least leave a sign. You found Hudson's house, like that, or whatever.
DJ, the thing is, I'm gonna have to make
a lot of recipes are given like this. I'm just trying to make us refocus because some of us are off focus. They will tell you, here's how you make a double batch, which is 2 regular batches. Now, if you want to cut it down and only make a single, maybe your party's not as big, you then have to do some math. Now, mathematically, this works perfectly fine. I will make the caveat, the disclaimer, that if you try this baking, your parents or grandma or whoever will tell you it doesn't always actually work. So it's just like this special thing with how cooking and baking and things work. It doesn't always perfectly work. Mathematically, we can do it. It'll make sense. It's fine. It doesn't always taste quite right. Okay, so just to warn you, this works for math. Taste sometimes gets slightly altered really quickly.
This is why I despise those recipes that do this, because like if it doesn't do some things like that, sometimes you don't change at all. But
Yeah.
sometimes you always add a little bit extra when you're making it regularly.
And sometimes they'll have a
It's
note.
really annoying on recipes. I'm just like, I don't need this. I hate this. You have to convert your entire recipe, and sometimes they're really long.
All right, we got to keep moving. So this was for a double batch. To get the unit rate for the single batch, or the constant of proportionality, here it would be the cups per, what is my denominator now? What do I want one of? Batch, right? So I want cups per batches. So we will do 2 2/3. Break it apart. What's 2 cut in half? 2/3 cut in half? 1 1/3 cup per batch. Bless you. And of course, then, and I hate when they ask for the equation first, now it's easier to write the equation. Because now I can say, cups of flour needed will be what? Izzy? 1 1/3 always? Per batch, which actually, be careful, that 1 1/3, even though we can say per batch, that now doesn't mean divided by batch. It means times how many batches you will cook. Give me your eyes for a second. This is our y equals kx, because batches is my independent variable. Cups depends on batches. This is your x. This is your y. If we wanted to rewrite it in y form, we could rewrite it. Y equals 1 1/3 x. We could write it with the x and the y. But just think, what's independent? I choose my batches. Then my cups are determined by my batches. Make sense? Independent, dependent. And we were gonna make posters, but I don't really like using all the poster paper and everything. We don't have that long today. We might come back to this on an activity day, just to make some more visuals for my room. I want you guys right now, because we have about 4 minutes, take 2 minutes to think of a situation, and ignore the learning log too, because I'm going to make up my own. This is really hard for me this year, by the way, to go with a textbook. I used to make everything on my own. And I could be like as creative as I wanted. I could bring in the projects that I was doing. This is tough for me transitioning to a textbook. So ignore the next stuff. I want you, not have to, but I like CPM. I want you in your toolkit or wherever you're taking notes to write down a situation that you've experienced, or you can make one up if you really don't think that you have one in your memory, that is proportional. When or what or whatever you think, like when you're running for gym, or when you're making cookies, or when you're looking at profit, or when you're thinking about like pairs of clothing, making a bracelet, or like think of a situation or make one up. Take 2 minutes right now. So how many siblings are there total? So you could like write a situation, like if me and my siblings get, or my siblings and I get 10 pounds of candy and have to split it, how much will we each get? Then that would be a proportional relationship when you would say each person gets so much. You know? And you could write it a few different ways. You could also, if we get, half a bag of candy every hour, how much candy do we get? Like that sort of thing. So yeah, you got options there. 30 seconds. Have it written down. Then share with your group. When ready, then share with your group. Share with your group. Maybe your group members will jog your brain. If you relate it to something proportional, like how long it takes. Like if I get my hair cut with 3 layers and it takes an hour, how long would it take to get 6 layers? But I don't know anything about haircuts with layers. I don't know if that makes sense. Like I don't know. Yeah. Might be proportional, so you could divide out to see what one piece costs, or how much you can get for $1. You could look at 2 different unit rates. A lot of situations have 2 different unit rates. Hey, so I'm going to steal you back for just a minute. A lot of situations have 2 different unit rates. May just asked me, so what if I say 15 pieces cost $2? I have 2 options there for unit rate. I can either say I can get 7.5 pieces for $1, or I could say how much does it cost per 1 piece. You can choose which is, because really we can determine which variables which. When we get deeper into independent dependent, really cost will depend on pieces. So this is actually what we would want, is the cost per piece. We normally want cost on top. Normally. That's not an always situation. Take the last minute that we have to share your situations with your group, and then we will be wrapping up that minute. Sure. That's a wonderful unit rate.